So let us take question number 9. Question number 9, they have given one Mohr circle, coordinates also given. As we already know, it is a graphical representation between normal stress and the shear stress. So the Mohr circle diagram seems to be like this. So this is the origin point I am taking as O. This is the center of the Mohr circle C, extreme point A, extreme point B. The A is having coordinates 1000, 0, and the B is having coordinates minus 650, 0. So these are in megapascal generally. So from center, this is the one radial line, intersects at this point. I am taking as L. So this OL generally is one of the inclined plane which is making 60-degree angle with respect to CA plane. Now in this question, our aim is to calculate angle of obliquity with respect to CL plane, angle of obliquity. So before going to that, first you need to know what is meant by angle of obliquity. Every point on the periphery of the Mohr circle is having two coordinates, one is sigma, one is tau. So those are called normal stress and shear stress on respective inclined planes. Similarly, CL is also one of the inclined plane. So at this extreme, what are the coordinates are there? Those are called sigma n, tau n. Normal stress, shear stress on this inclined plane. The inclined plane is making an angle of 60 degree with respect to CA plane. So here, this height can be called as a tau n. This can be called as sigma n. Now, by taking these two, there is a possibility to calculate resultant stress. The resultant stress line seems to be like this, passing through origin, sigma r, that is making an angle with respect to horizontal is theta. So angle of obliquity is exactly defined as the theta value. So this triangle I am going to draw again. So this is the triangle. This is the origin point O, the center point C, and this point is L. So this height is a tau n and this value is a sigma n. So this value is given 60 degree, and here we need to calculate the theta value. Theta is called as angle of obliquity, right? Now, so to calculate this thing, first if you know the value of CL, CL is exactly called a radius of the circle. If you know the diameter, then it is possible to calculate the radius. What will be the diameter from origin to here? O to A, the value is 1000. From O to B, the value is 650. The total diameter will be 1650. The radius will be divided by 2. There you will get the value of 825 megapascal. So this is 825. Right? Now, how to calculate OC? From O to A, it is 1000. C to A is the radius. CA can also be called as radius because C is the center of the Mohr circle. So whereas O to A is 1000, C to A is 825. Then how to calculate OC? 1000 minus 825 will be 175. Right? Then the sigma n value we can resolve. 825 cos 60. And this will be 825 sin 60. And how to calculate? So by using tan theta formula, opposite divided by adjacent. 825 sin 60 divided by 175 plus 825 cos 60. Find this value, take the tan inverse, there theta you will get as a 50.56 degree. This is the angle of obliquity. Correct answer for this question. Like this you need to solve if it is a case of gate question. But here I am going to discuss some more information regarding to this problem. Key points of Mohr circle. The first key point is center of Mohr circle is always lying on sigma axis. Center of Mohr circle is always on sigma axis. This is the first point. Similarly, the second point is radius of Mohr circle is exactly given as, this is a sigma 1 maximum principal stress, this is sigma 2 minor principal stress, major principal stress, minor principal stress, sigma 1 minus sigma 2, this is mod divided by, this is the usual formula to calculate radius of the Mohr circle. But here sigma 1 is 1000, sigma 2 is a minus 650, so minus into minus it will become plus, so total will be 1650 divided by 2. This can also be written as maximum shear stress magnitude, tau max. Keep it in mind, like this one of the question they will ask. The radius of the Mohr circle for the stresses is a maximum shear stress value. So this is the radius, correct? Exactly here, maximum shear stress will be there, right? So let us say I am taking this point as D and I am taking this point as E, right? Now if you look at the circle carefully, CA is one plane, CB is another plane. For these two planes, the value of tau is 0 and the value of sigma may be maximum or minimum. So keep this point, this is very important. CA is one plane, CB is another plane. So these two planes are having the value of shear stress as 0 and the value of normal stress either may be maximum or minimum. Those planes are exactly called as principal planes. The basic definition of principal plane is like this: the plane where the shear stress value is 0 and the normal stress either may be maximum or minimum. So the plane is exactly called as principal plane. So if it is a maximum normal stress is there, that can be called as a major principal plane. If minimum normal stress is there, that can be called as a minor principal plane. There are two principal planes are there. These two are separated by 180 degree in the Mohr circle, but in reality, in the member, actual member, it should be 90 degree. It should be 90 degree. From this, what we can say? In the Mohr circle, if the angle is 2 theta, but actually that will be theta inside the member. Let us say in the Mohr circle here, the CL plane is making 60 degree with respect to CA, but in reality the CL plane is making 30 degree with respect to CA. Keep it in mind. So here it is 2 theta, 60 degree is 2 theta, but in reality that will be theta 30 degree, right? In a similar way, this is one of the plane CD, this is another plane CE. So CD and CE. Here shear stress value is maximum, but normal stress may be 0 or may not be 0. So clear? May be 0, may not be 0, but the value of shear stress will be maximum. So these type of planes can be called as maximum shear stress planes. There are two maximum shear stress planes will be there. Those two are separated by here 180 degree, CD and CE, but in reality those two are separated by 90 degree, right? If you combine all these things, here the principal plane, the shear stress plane, both are separated by 90 degree, but in reality it will be 45 degree. So the total representation that we can take like this. Right? Let us say this is the plane which is making an angle with a theta 1, this is theta 2, theta 3, theta 4. Theta 1, theta 3 both are separated by 90 degree. Theta 2, theta 4 both are separated by 90 degree. But these two are separated by 45, these two are 45, these two are again 45. What are theta 1 and theta 3? Theta 1 and theta 3 are principal planes. Principal planes. Where theta 2 and theta 4 are tau max planes, maximum shear stress planes. These two are separated by 90 degree, these two are also separated by 90 degree, but one principal plane, one shear stress plane separated by 45 degree. That point you need to remember as an interview point of view. So similarly, another point also we can discuss. If you take this point as a F, then C2F is also one of the plane, CF. So exactly here the coordinates are normal stress is 0, but the shear stress is there. Keep it in mind. CF is one of the plane where shear stress is not equal to 0, but normal stress is 0. The plane where normal stress is 0, but shear stress is not equal to 0, these type of planes are called pure shear stress planes. Pure shear stress planes. Listen, there is no perfect relationship between tau max planes to pure shear stress planes or principal plane to pure shear stress planes. The pure shear stress planes location will depend on type of loading conditions, the type of Mohr circle. So like this, you need to remember some of the information regarding to it, the key points for regarding to Mohr circle, right? Some more information also I can discuss. Let's say in some of the questions I am going to discuss some information regarding to Mohr circle. So listen, keep it in mind, this circle is very important. So this point is a C, this point is A. So CA is one plane, CL is another plane, CD is another plane, CF is another plane, CE is another plane, right? So like that, how many planes I can draw? Infinite number of planes. So infinite number of planes is having some coordinates at the outer periphery. Those will give a tau value, sigma value with respect to that plane. This is very important. The Mohr circle will give the normal stress, shear stress values at any plane instantly. This is one of the significance of Mohr circle. So one of the interview question they may ask, what should represent a point which is inside the Mohr circle? Let us say this is the point P inside the Mohr circle. So the point P is having the two coordinates, tau and sigma. But even though the point which is inside the Mohr circle, the point which is inside the Mohr circle represents nothing. Keep it in mind. To get confused, they may ask this type of question also. The point which is inside the Mohr circle represents what? Like that they may ask in the interview. Keep it in mind, it represents nothing. The points on the outer periphery of the circle will represent sigma and tau. Except these, the remaining points represents nothing. Right? Keep it in mind. This is the information I need to discuss. And one more point. What do you mean by inclined plane? Let us see if you draw the state of stress like this. This point I am taking C, this point I am taking A. So this is the plane called a CA plane, CA plane. And this is the point L I am taking. This is the plane called CL plane. So inclined plane with respect to CA is making an angle of 60 degree here, but it should be 30 degree. So for this inclined plane, there will be a normal stress sigma n, there will be a shear stress tau n because of the application of loading. So like this, how many number of inclined planes we can make? Infinite number of inclined planes we can make. Those are all number of inclined planes will be represented inside the Mohr circle. So for all those inclined planes, the value of sigma, the value of tau is given directly from the Mohr circle, right? Keep it in mind. So for CL plane, the height is given as tau n, whereas this total value is given as sigma n. From here to here, this magnitude is there, that can be called as sigma n. This height can be called as tau n, right? So graphical representation, you should be very strong regarding to graph. Right?